Old mud and tree rings will help to determine the effects of climate variation and human impact on the New Zealand shelf ecosystem.
The fish! The fish!
In July 2006, a 3-year project was initiated at New Zealand's National Institute of Water and Atmospheric Research. Under the leadership of Dr. Alison McDermott, 25 scientists analyzed the changes in New Zealand's coastal marine environment caused by human impact and by the climate.
Our goal is to build carbon flow models of our shelf and coastal ecosystem for 5 different critical periods over the last 1,000 years. Now, this is going to give us a clearer understanding of the present and past states of our marine ecosystem so we can develop a clearer vision for its future.
By analyzing data such as rings from giant kauri trees, sediment cores, sections through stalactites from limestone caves, and other sources, they will be able to establish a climate chronology for the last 1,000 years.
The trees, the cores, and the other sources contain a record of how New Zealand's climate has varied over the last 1,000 years, the entire length of human occupation. These indicate variation in the strength of the coastal winds, which drive increases and decreases in upwelling and coastal productivity, and thus the flux of carbon through the system. And we need to take these into account in our models. But because New Zealand is very active geologically, with the many earthquakes and volcanoes and tsunamis, we also had to take this into account in our modelling. A good example of these sorts of occurrences is Rangitoto Island here, which just lies at the mouth of the Waitemata Harbour. It erupted only 600 years ago in 1400 AD, over a period of 10 years or so, and not only greatly affected the local Maori settlements, covered them with ash, but also greatly affected the marine ecology of the inner harbour itself.
Compared to the rest of the world, New Zealand and its surrounding marine ecosystems have only very recently been affected by humans. The Polynesians settled here 750 years ago, and ever since that time, the marine environment has been increasingly influenced.
This recent arrival makes the prospect of distinguishing climate variation and human impacts much more tenable here in New Zealand than in other places where humans have affected the margins of the sea for tens of millennia, but climate has also undergone large shifts.
When the project ends in 2009, New Zealanders will have a much better understanding of the sea surrounding them. Secondly,
because it all occurred over a short period in a well-defined and isolated locality, it is the story of human impacts on the world's coastal seas, but on a comprehensible scale. For this reason, the New Zealand story needs to be told worldwide.